All right, 7-5 homework, 10 questions. I think what you'll see is they increase in difficulty as you go for the most part. The first few should be pretty straightforward. We have 2 times the sine of some angle equals the square root of 2. And we're supposed to find solutions that are in between 0 and 2 pi. I think when you solve this equation, you'll see that we're looking for points that you have memorized off the unit circle. You put those answers in here, and you're done. In fact, it's the same thing in question 2, where you solve this guy, you get some answers. They should be numbers off your unit circle, and you're good. 3, I guess, is a little bit more complicated because now you have something squared, but if you take the square root of both sides of the equation, you should be in good shape. Just don't forget the plus or minus when you take the square root of both sides, but nothing too fancy going on in 3. 4 is kind of similar to 3 in that you have something squared, and you might look at this and be like, oh man, I have to factor this thing. Now, you don't have multiple terms that say cosine in them. There's only one x in this equation. So just get cosine squared x by itself and take the square root of both sides. But much like in question 3, when you take the square root of both sides, make sure you put in the plus or minus. I think we're still at the part of the homework where these should all end up being memorized values off your unit circle. Question 5 gets a little bit harder. It's more like the advanced equations that you saw in the second video, because I think what you're going to have to do is factor this guy. The nice thing is it's already set equal to 0, so the factoring you'll have to do kind of on the front end won't be so bad. The leading coefficient is not a 1. That'll make things a little bit harder. If you have a really hard time factoring this, maybe instead do 2y squared plus 3y plus 1 and work through that whole problem and solve that. And after just doing that, I bet you'll have an easier time with this. Get your answers. If I remember right, these are off the unit circle as well, and then you're good. 6 is a little bit more difficult because you have sine squared here, but you have cosine here. It's unfortunate when those don't match up. Fortunately, I did a problem in the second video where we had that exact same case and we used the Pythagorean identity to change these. I think you'll want to do the exact same thing. Use your Pythagorean identity to change sine squared into something related to cosine squared, and then maybe you'll have an equation that you can factor and solve. 7's kind of like 6. You got sine squared, and then you got cosine squared, and then you got sine here. So we have sines here and here, but these are cosines. Maybe you could think about changing these cosine squareds into sine squareds using your Pythagorean identity, and maybe that would give you an equation that you could solve. In fact, I think that equation is going to be really similar to this equation, but what are you going to do? Then we get to question 8. I believe question 8 and question 9 are the two on the homework where, when you solve these equations, you'll end up with values that are not memorized values off your unit circle. They ask you to enter your answers accurate to 2 decimal places. They're assuming you're going to use a calculator, but I think you can do these without a calculator if you want to just leave arc sine or arc cosine in your answer. But just beware for questions 8 and 9, it'll be the more difficult type that I talked about where the angles are not memorized values off your unit circle. The equations themselves, I don't think are that much more difficult. For this one, we start out with the quadratic trinomial. So set it equal to 0, that's already done. And then factor it and solve. Getting to the stage where you have cosine of x equals some number and cosine of x equals some other number won't be too bad here. But it's that last step where you have to involve arc cosine, which might give you a little bit of trouble. This is kind of a weird looking equation. My hint here is add the 3 sine of t over to the left-hand side of the equation, because then you'll have something set equal to 0. And something set equal to 0 is really nice if you can factor. And I think you will be able to factor after you set it equal to 0. Look for something that both terms have in common. This should be similar to the last example that I did in the second video in this section. And then finally, the extra credit one. I made this extra credit. It's not even that much harder than the rest of them. It might be easier than some of the other ones, but I didn't show you how to do this, so I decided I'd make it extra credit. The idea here is you see sine of 2x. Not sine of x, but sine of 2x. This says cosine of 1x, but this says sine of 2x. How am I possibly going to solve that? Well, they kind of tell you how to solve it. They say use a double angle formula. It actually says use a double angle or half angle, but I'm telling you that if you use a double angle, it'll make your life a lot easier. You have a formula that allows you to rewrite the sine of 2x. I believe it's equal to 2 times the sine of x times the cosine of x. But whatever, go back to your 7.2 and 7.3 formula sheet and replace sine of 2x with what it's equal to in that formula sheet. And that will give you an equation that I think you can solve. The mechanics of solving that equation will be kind of like question 9, and you set it equal to 0, that's already done. And then you look for a common factor and factor something out. But I think what you'll find is 10, unlike 9, the answers are values off your unit circle. So it's going to work out so much nicer. So I think 10 will be an extra credit question that you actually kind of like. The only reason it's extra credit is because I didn't explicitly demonstrate one where you use the double angle formula. And then that's it.